notice how similar these two problems are, the only difference being x squared here and x to the fourth. And yet the way that we do these problems are going to be quite different. So that's sort of the point of this one, is that when you look at an integral, you've got to really have an open mind, because it doesn't take much to make the work quite different. So with this one, I noticed that if I let u equal the inside part, the derivative of it would be a 2x, and that's essentially what's sitting right there. So for this one, I would use u substitution, take the derivative of that with respect to x, and this one has x dx, and this one has x dx. I just need to multiply by a negative 1/2 on both sides. And then this x dx is going to replace this x dx with a negative 1/2 du. So let me just split the page. So the one on the left is going to become integrate. The top part is going to become negative 1/2 du. The negative 1/2 I can put here, and then du. That takes care of that red part. And then this is going to be the square root of u. Remember, with u substitution, it's very important that you work with all u's or all x's, never a mixture of the two, at least not until third semester calculus. So for this one, to integrate it, I would rewrite it as u, so integrate u to the negative 1/2. So we'll add 1 to the exponent, and it will become 1/2, and then divide by that. So you get u to the 1/2 divided by 1/2, and the negative 1/2 is still out in front, and then plus a constant. Well, the negative 1/2 and the 1/2 are going to cancel, leaving just the negative sign behind. And then this one is going to be the square root of whatever u was, which was back here 1 minus x squared, plus a c. And then for this one, well, if I tried u substitution and had u equal 1 minus x to the fourth, the derivative would be 4x cubed, and this doesn't have any x cubed. So this part up here is missing x's for my u substitution, and there's really nothing you can do about missing x's. So u substitution, at least that u substitution, letting u equal this inside part, that's not going to work. But if you recognize that this one, like if we were integrating 1 over the square root of 1 minus x squared, well, that comes from the derivative of sine inverse. And so this one is essentially of that form, but I need to look at this one as integrate and rewrite x to the fourth as an x squared being squared. So essentially it's saying the square root of 1 minus something squared, this being the something. So 1 minus something squared. And that's what this is, the square root of 1 minus something squared. And the something is this thing right here. And so this is going to be the u. And then this would be 1 minus u squared, just like this is 1 minus x squared. So then we'd have the derivative of u is going to be a 2x with respect to x. And that works out perfectly because this has x dx and this has x dx. I just need to multiply by 1/2. So 1/2 du is equal to an x dx. And then it's ready for the u substitution. So we're going to get integrate. So x dx gets replaced with 1/2 du. 1/2 du. And then it's 1 minus, this is u squared. So square root of 1 minus u squared. And that right there is sine inverse. So you'd have 1/2 sine inverse of u plus a constant of integration. And finally, replace u with what it's equal to in terms of x. So we get 1/2 sine inverse of x squared plus a constant. And you can see the two answers look completely different, even though the original problems only had one little thing that's different.